I welcome you all to another class on Statistical Inference, and today we'll be looking at hypothesis testing. So this will be the first class on hypothesis testing. So we shall be looking at the basic principles in hypothesis. But before that, let's recall some vital informations in our previous class, which will guide us. Remembered, we talked about this course is all about statistical inference, and we said statistical inference a way or process of which we get hold of an information about a population through samples, right? And which will talk about how statistical estimation has been drawn as a result that what is not visible is not achievable to get all the elements in the population. Hence, we relied on sampling, and every sample we drawn, we can use the sample statistics to draw out estimations, and that is what we did in our last class. So the second part of statistical inference is what is hypothesis testing, and that is what this subsequent class from here will be all about. So let's look at the hypothesis itself. First of all, we'll look at the definition, the meaning of hypothesis. Generally, we said hypothesis is a tentative assumption that has been proposed for the sake of an argument in order to know if the argument can be said to be true or not. So is a tentative assumption. It's an assumption. So for every hypothesis, you said there is always a decision at the end to either what accept the hypothesis or reject. So it's a tentative assumption that is just being proposed for the sake of an argument, and the argument you have is putting the available resources or evidence about the assumptions available, then analyze it. The result at the end will now have a result, and the result will either depict, will reject, or will accept. So, and the plural form of it is just changing the I between the between the S's to E. So let's look at examples of tentative assumptions that we make day to day in our daily activities. One is look at employees who bring their lunch spend less money throughout the day. So it's an argument. Oh, man, try to put that on a debate. Oh, workers that comes with their lunch to work, they tend to spend less in a day. So that involves us what? Getting all our informations on who bring lunch to work, and the how much or the total money they are likely to spend daily. So these are what. So when you compare that, when we now put that into test, we then decide, oh yes, the statement can be rejected or can be accepted. So the same is applicable to the second scenario. Students who don't miss lectures have better academic performance. So it's an assumption. If you don't miss lecture, you should have a better assumption, as in better performance. So which could be right and could be wrong. And the last one is also students who use shuttle bus spend less money throughout. So these are some examples of hypotheses that we make. So what is now the testing? For every hypothesis, there must be process of testing. They must be tested in order to know is that we reject or what or will accept. So for every hypothesis, there are what hypothesis emanates emanates from what? From statement of problem. So there's always a problem at hand, or there's always a focus or study at hand that you want to understudy. You understand? There is always an issue you want to find a solution to, and this issue definitely would belongs to a certain population. So hence why we describe the okay, given a population, let's assume that a population is your group of interest or problem of interest, okay, with a parameter of interest. So in that population there's a parameter of interest. So for instance, when we talk about employees that brings their lunch to work, spend lesser. So the employees there, the workers they have, they are the what? They are the population. While a parameter is all about, parameter of interest is all about what? Who brings lunch to work and money they spend daily. So these are all refers to our parameter of interest. And in numeric form or statistical form, we say we can represent this by mean, by variance, by standard deviation, or proportion, as the case may be. So we would like then to now decide to choose two contemporary complementary statements about this parameter. So when you set your parameter now, we then now look at it, okay, let's look at how we'll come up with a complementary statement. Two complementary. So that means one we state A, B will complement A. So that means by complement. So it's not just these things, they are not independent. They depend on one depend on the other. So that means by what to complement. So they must complement each other. So when we have such a scenario, what we say we have what is what we call statistical hypothesis. Is what we refer to as statistical hypothesis. I hope that is clear. So the choice of this of decision between these hypotheses that will state to is to be based on what? The sample you collected that is drawn from your population of interest. You understand? So that will now inform is either we'll go for the hypothesis you state A or you go for B. So the ideal goal is to be able to choose the hypothesis that is true in reality based on the sample data. That's our ideal goal. So what is the goal, general goal of your hypothesis, statistical hypothesis? So it's for us to for us to make statements regarding the unknown population parameter. So that is the goal of statistical hypothesis testing. One is for you have to draw up a statement or two statements, complementary statement about that unknown population. And for you to draw this, so we have the elements that constitutes hypothesis testing or statistical hypothesis testing. One is what we call to null hypothesis. The null hypothesis here means null, means always refers to a what? Hypothesis of what? Of no effect in statistics. We assume that nothing happened. So it's a statement regarding the values of unknown. So typically it will imply no association between the explanatory and the response variable. So these are what we refer. So you will always say, okay, there's nothing happening. So that's why we call it null, an empty. Oh, there's no relationship. Oh, there's no effect. So these are what refers to as what? Null hypothesis. So the alternative means what? It's just the statement that contradicts the null hypothesis. So if here is saying that there is no relationship, this here will be saying that what there is a relationship. So it must complement. It always complements null hypothesis. And for every statistical hypothesis, there is what? test statistic. So the test statistics here now refers to your what? Remember what we mean by statistic is a function of what? Of your sample. Good. So the test statistic now is what? Is the statistic, the instrument that you will use to estimate, now to give you the estimate for your statistic. So that's what we test statistic. And this is the value from here. Any values you derive from your test statistics will then have used to make decision in the rejection region. Do you reject or you should accept? So these are the four major elements in statistical hypothesis testing that you must familiar with. So we'll still talk more about them. So while performing hypothesis testing, there are certain decisions we are bound to make, and in these decisions are partitioned into 4 segments. So when you look at the slide here, you see that we have 4 segments. We have a 2 by 2 contingency table, so we have 4 segments. So we are bound to make these decisions, and when you look very well, there are 2 scenarios we will describe here. Here is your test result, being the vertical decisions, and here we have the true state, the reality in reality. So what you decide on against the reality. So that's 1 by 2 by 2. You understand? And from here it has to have 2. It forms 4 parts, 4 segments. So let's look at the first scenario. The first scenario is that what we in your test result, your H naught. So the H naught here means what? Means your null hypothesis. So it's all about null hypothesis. What you state to have no effect, no association. So it's also a null hypothesis. So here now, what will have your null hypothesis to be true, and in reality is true. So you make a correct decision. And in a case that you make decision that your H naught, your null hypothesis is true, meanwhile in reality is false, we say you commit a type 2 error. So, and when you move further, your results depict false. That means is false. In true life, it's not false, it's true. That means what? That's type 1 error. And the last decision is when your result to be 4 and in reality is false, hence we say it's correct decision. So we are about to make two types of error in our decisions. So in statistics, we are conscious of these errors and we'll need to fix them, and it's important for us to know which one is more severe, which one is less severe. So let's say for instance, we said type 1 error. What do we mean by type 1? Type 1 error, what it occurs when you look at it here. It occurs when an H naught is rejected, given is true. Look at it here. You reject it and it's true. That's what we call type 1 error. And type 2 error is what? Not rejecting your H naught when it's actually false. That means you are accepting the null hypothesis when it is false. And the probability of us committing type 1 error is what we refer to as alpha, and the probability of us committing type 2 error is what we refer to as what? As beta. So let's look at it. Which one is more severe? Let's look at this scenario. So we want to understand which one is more severe. And in the scenario is what we're looking at: court settings. You understand? The court settings, when you have what every defendant is presumed to be what? To be innocent. So that's the null hypothesis, right? That you are innocent of this offense. So there is a need to provide all necessary evidence in order to be sure, in order to convince the defendant. You understand? So if there's no, so it will go extra mile. There will be extra mile. It will go extra mile for the prosecutor to what? To present necessary evidence in order to what? To convict the defendant. So while making this decision, we consider two errors. So let's look at this error, and you would agree with me that one is more severe than the other. In a situation where a, a defendant a defendant is innocent of an offense, is not guilty, is actually innocent, but the judge asks the judge convince the innocent person, either pass judgment that, oh, you are guilty, hence being sentenced. So that's one error. And another scenario is that when the defendant is actually guilty but was set free, is being set free. So that's another scenario. So we have two types of scenario there. So the one of which one is now more severe? When you look at it critically, you realize that what? When a defendant that is innocent being then now being convicted, then now being sentenced, then now we say, oh, you are guilty, and then being sentenced. For instance, if it's issue that has to do with what? Murder, and this person is being sentenced to what? Hanging by death. That means you've that seems to be more severe because there is no a second chance for the person to represent his case. Rather, it will be just and truly this person is innocent. So this person will be sentenced. So we consider this scenario to be what? To be more severe, and that's what we call type 1 error. And the type 2 error type is what is a someone that is actually not guilty. Actually, the person is guilty of this offense but was set free. So definitely, this person can still be invited back when you have the necessary document or necessary evidence in order to convict the person. They can be invited back and be sentenced. So therefore, we refer to that as this is less severe, and that's referred to as type 2 error. So in reality, in statistics, what do? We try to fix the type 1 error and try to minimize the type 2 error. So that's why every time in our analysis, in our text, we'll give a specific value for the probability of what? Committing type 1 error. And that is the alpha. Why the beta is always being silent about, and that beta is always used, we will minimize it. I hope that is clear. So in trying to minimize, however, the probability of type 1 error, we encounter an obstacle because of what? Because the moment the probabilities of type 1 and type 2 error are inversely related, you understand? So if you try to minimize one, what you are doing is what? You are increasing the other. So what do? We fix one with a certain value, then in order to minimize the other. So what we do that does, if we try to make the probability of type 1 error very, very small, then it might make the probability of type 2 error quite large. So as a compromise, we therefore specify a maximum tolerable type 1 error probability, which is normally called alpha, so level or significant level. So in order to minimize the type 2 error, so that alpha is always being considered, and conventionally we set alpha to be what? Either to be 0.1, 0.05, or 0.01, 1%, 5%, or 10%, as the case may be. So what are the steps in performing statistical hypothesis testing? One is state your null hypothesis and alternative hypothesis correctly. Remember, the null hypothesis was hypothesis of no effect, no association. So we assume nothing happened. While the alternative will be what? It will complement your null hypothesis. So it's very important to be able to state your null hypothesis correctly. And the second one is that you understand the population of your interest in order for you to be able to determine your sample size and know other characteristics of your sampling, which could be mean, proportion, standard deviation, and so on. And the next is what? Fix your level of error, especially type 1 error, alpha, to be whether 5%, 1%, or 10%. And the other one is what? You state your decision rule. Oh, you reject. So if your test statistics is so level, so you take your decision rule, when to accept or when to reject. And the next is to compute your test statistic. So depending on your level of your your null hypothesis, you can now use your test statistics in reference to your null hypothesis, and you estimate, you compute. So that value there would be compared to your your decision rule, and you now decide is either to accept or to reject. So once you accept, reject, hence you have to conclude, tell us what it implies, and that is the inference we're talking about. So that makes it statistical inference. You understand? So at every point, at the end of your testing, you must draw a conclusion. That conclusion is what we refer to statistical inference. And that conclusion is found to be what? To represent that population of your interest. I hope that is clear. Thank you. You can look at this in order to assess ourselves privately. You can look at this scenario. We have questions that you can try to assess. So let's look at it. A researcher is testing a new drug for a disease. The null hypothesis is that the drug has no effect. The researcher finds a statistical significant result, leading them to reject the null hypothesis. However, in reality, the drug has no effect. What type of error has this researcher made? What type of error has this researcher made? So please, you can drop your comment. This will guide you. Remember, with the other scenario I made, so it's similar to this. The hypothesis is that what? There is no effect, but the researcher happens to reject the null hypothesis, given that is true. Remember your alpha. I think I've guided you. The second one is what? Medical test is designed to detect a certain disease, which is perhaps HIV. The null hypothesis is that what? The person does not have the disease. The test comes back negative, and the researcher fails to reject the null hypothesis. However, the person actually has this disease. What type of error has this researcher made? Remember the two types of error. Try to assign them. Look at the one that is more severe. So I've guided you on how to do this. I believe you can find the right answers to this. And if you don't find, please drop a note, drop a comment for us, and we'll provide the answer to that, or perhaps we'll provide this answer to that in our next class. The third one is, what are the potential consequences of making a type 1 error in a clinical trial? You should know that that's costly, very, very costly. 4. What are the potential consequences of making a type 2 error in a criminal trial? Remember my earlier scenario. Go look at it on what it will be. Setting the okay. The next one is, how can researcher reduce the risk of making a type 1 error? What do we do? How do we do it? How do we manage it? And 2, the last one, how can a researcher reduce the risk of making type 2 errors? All these, please drop your comment. If you have any if it's not clear or you cannot provide answers, you can hit us up, as in by dropping a message or a comment in the comment section. And thank you. That brings us to the end of today's class.